Hey guys, quick little note before we get started with this lab video. I actually already recorded the solution for this, but my headset was off, so there was no audio input. So this one's going to be a bit shorter. Sorry for that in advance. But today we're working on activity 8.10. This is lab number 8, and it's this course grade assignment. So the purpose of this assignment is kind of just to get familiar with streams. Not so secretly, we've already been working with streams with our C in and C out. Those built-in um, IO streams buffers. Anyways, uh, we're going to gain some proficiency with streams in general using file streams. Of course, there's all sorts of streams. There's string streams, file streams, just basic IO streams, things of that nature. But yeah, so generally this assignment it's very practical. There's going to be lots of useful applications from this kind of a topic. Reading data in is just a very common task, reading data in from a file and then redirecting some processed data from our program out to another file, equally common. That was loud. Sorry about that. But yeah, without further ado, let's get into it. So yeah, so we have this program that reads in student information from a tab separated values file. This isn't too important. It's kind of, the name is self-explanatory. We have this file where each of the values are separated by tabs. Shocker. Um, and then the program's going to create a text file that records the course grades of the students. So each row contains last name, first name, midterm 1 score, midterm 2 score, and the final score. So we have these categories of data. So already we're thinking, okay, we're going to have a bunch of the same kinds of data. So maybe we should be thinking about how we're going to store this data. Hint, hint, vectors, right? Vectors are sort of our only container that we're very familiar with at this point, and they will do just fine for storing each of these categories of data for us. So we have a sample student info, which I've already looked at in the studentinfo.tsv, and then we want to assume the number of students is at least 1 and at most 20. So this is our first assumption, and this is going to help us out a lot because we know that, okay, this is going to help us initialize our containers in a way that will reduce the complexity of our code. And then additionally, we want to assume that the last names and first names don't have any white spaces inside of them. This will just help us read in the data from the file without having to worry about some extra input sanitization techniques. So we want to do the following things. We want to read the file name. Okay, so that's pretty simple. We know how to read strings from users. Then we want to open the file. Okay, so this is where we get into this file stream stuff. We want to open the TSV file and read the student information. So reading information from a file is actually not too different from reading it from standard input, but we'll get into that when we get there. And so we're going to actually need some input file streams to take care of this, and yeah, we'll go over that a little bit later. So before I continue with the prompt analysis, I just want to go over some of these include statements. So everything, hopefully you've already seen here. We've got our string library. IO stream is just for like C in, C out, stuff like that. IO manipulation, so this is going to be for like formatting output data, like the set width, set precision, fixed decimal point output, all that sorts of stuff, all those sorts of stuff. And then file stream is going to be the really big one here. So f stream is going to give us our input and output file stream objects, right? Okay, so let's continue. So after we've successfully read in all the information, so we've read it and stored it into our vector containers, we're going to compute the average exam score of each student. So try not to confuse this with the next task. We're going to take the data from each student and assign a letter grade based on their exam average. And then later, we're going to compute the average of each exam overall. So like the class average. So we're going to say, okay, midterm 1 average was this, midterm 2 average was this, so on. Then we want to output the last names, first names, exam scores, basically all of the data from the initial input file, and also the computed letter grades into a text file named report.txt. So this is going to utilize our output file stream. And then we are going to output our averages in this specified format right at the end. So the only difference in our report.txt file is it's got the exam averages at the very bottom, and it's got the letter grades right to the right. So there should be an example over here. So yeah, so like this is our file name string. This is our file contents, and this is our report.txt resulting output file. As you can see, the only difference is the letter grades for each student, and then the exam averages there at the bottom. So let's go ahead and get started. So hopefully we have this outline here. We've got these to-do statements. So first of all, we want to declare any necessary variables we might need. It's not always immediately obvious what variables we'll need throughout the program until we actually need to use them. So we'll just get down everything here, but it's totally fine if you are working through the development of your own program and you don't realize you need a variable until later. Just go ahead and add it to the top here and then utilize it down below wherever it is that you need it. So we already talked about we're going to need some vectors, right? So how are we going to store this data in vectors? So we know that we have a category. We have these categories, right? So we're going to have 1 to 20 records. A record is just a line of data corresponding to one individual student. In this case, a record corresponds to a student. And we're going to have 1 to 20 of these. And we know that each record is going to contain a last name, a first name, midterm 1 score, midterm 2, and midterm 3 score, right? So we just want to somehow store all of this data in an organized way. So what we can do is we can just have a vector for each category of information. We could have a last names vector, a first names vector, midterm 1 vector, and so on and so forth. And that way, we can just use the indexing scheme as our record number. So our first record will be at index 0, and it will contain all of the information for this student if you just access each vector at index 0, right? So let's go ahead and declare our vectors for storing data. And we can use the parameterized constructor here because we know that we can have at max 20, and this will just help clean up our code a little bit as we go through it. So let's get that in there, and let's format this because it looks weird. Nice. Okay, so we've got some vectors. And then, so the first task that we had, if you go ahead and look to the course grade description, is we want to go ahead and read the file name from the user. So we're going to need to just, have some variable to store the file name. So we will need a string. We'll just call it scores file name. Let's declare that at the top. And then after that, we're going to want to open the TSV file and read the student information. So for this one, this is kind of the new stuff here. We're going to need an input file stream object. So that's just denoted as ifstream. So you can have an ifstream object. And the convention for naming these is just to use, some sort of identifier and then fs at the end for file stream. Right? So we have this ifstream scorefs object. And so we're going to use this to go ahead and open our file stream, or open our file for reading later on in the program. And then if we go down to our task, we're going to say, okay, eventually we need to output some stuff. So we'll kind of have the analog for the input stream here. We're going to have a string for the file name, which we can just initialize right away because we know it's going to be called report.txt. And then we're going to have an OF stream report.fs, which is going to just allow us to write to some external file. Cool. So we have a lot of stuff here. What else do we need? So we need to do some computations, right? So we're going to have some averages that we need to compute, and to do that we will need some double variables because remember, if you look at the program description, we will want these in double format with fixed point precision and 2 figures after the decimal point. So let's go ahead and get some variables for that. So what kind of stuff will we need? Well, for computing averages, we'll probably need an overall sum for each of the things that we want to average out. So for the midterm scores, we'll have midterm 1 sum, midterm 2 sum, and final sum. Let's go ahead and get those in here. And then we have individual averages as well, right? So for the individual averages, we will need some number. Well, this number is going to be multi-purpose. So we're going to have some integer n, right? We'll get more into why we'll need that later. Again, this is one of those things where it's like you might not realize you need it until later on in the program, in which case you can just go back up and add it when it is necessary, right? And then the average is just going to be for each individual student average, and then this will be used to calculate what our string grade for that student will be assigned, and then we'll just go ahead and output that to the file. Nice. So I think we've got all of our necessary data, declared all necessary variables, so we can go ahead and get rid of this to-do right here. Sweet. So let's go ahead and read the file name from the user and read the TSV file. So you guys know how to read file names. You should really be prompting for the data. I'm not going to do it here just because, like I said, short on time, and I already recorded this video, so yeah, unfortunately, I'm in a bit of a rush to get more stuff done. Anyways, so you just go ahead and call your cin statement, but again, when I say I'm prompting that we should be prompting for the data, we should say, okay, go ahead and please enter, your scores, file name here, or something to that effect. And then the user would know, hey, this is what it's expecting, so I can go ahead and enter that in, instead of just like a blank cursor where it's just waiting for something and the user may not know the purpose of the program, or even if they do know the purpose of the program, they might not know exactly what it is that the program is waiting for, or that it's waiting for anything at all, right? Not everyone is that fluent with technology. So now we want to go ahead and open let's get some space between that. We want to go ahead and open the file stream, or the file, both. So here we have to do some kind of input validation. So as far as actually opening the file, what we need to do is we just want to call the open file stream function on our scoresfs input file stream object, and then we want to use the argument of our string name that we've just read in for the student information file. All right, so this is going to open that file, and it's going to attempt to open it, I should say, right? So we want to make sure that the file opened correctly, right? So this kind of input validation is going to be a common task for us. We just want to say, okay, if it's not open, then go ahead and give some sort of error message. And again, we can use one of our file stream member functions in order to take care of this task. So we'd say, okay, if it's not open, then say this error message and then return 1. So you may have noticed throughout several of your programs so far in the semester that we have this return 0. So return 0 just means exit without error, and then anything else returns with like a certain error code. I myself am not super familiar with them all, but I'm sure there's some good C++ documentation out there to help you learn about what each one corresponds to. Anyways, so now that we have validated that the file is properly opened and we have not exited the program, assuming that it did open properly, then we can actually go ahead and start reading this in. So as some of you may be a little bit hesitant about this, like, oh, this is a file, it's completely different. But actually it is, very much the same. So we just want some way to access each index of each of our vectors, and we want to go ahead and assign each piece of information from our input file to its corresponding vector. So what we can do, so here, before I go ahead and give us the solution, we want to think about, well, what's our stopping condition, right? Because so far when we've read in data from standard input so far in the semester, right, through CN, what we've done is we have known the amount of data to expect, right? In some of our lab assignments we've had like, okay, enter a number of integers to expect, and then the list of integers, right? So like 5, and then whatever 5 integers come after that. In this case, we have a variable range of data, right? So it can be between 1 and 20 records. So what we'd have to do is figure out a stopping condition that is not related to, or it can be related, but that is not exactly the number of records that we should expect, right? And so since we're using a file stream, what we can do is we can just say, okay, keep reading in data until there's some failing condition. And thankfully we have another file stream member function to help us there with that. So what you want to do is we want to say, okay, so while there's not a fail bit or a bad bit set on the input file stream, and we won't go too much into detail in this lab video on exactly what those are, but basically if something hasn't gone wrong, then we want to go ahead and increase the index of the data that we are manipulating or that we're storing into. Not the most elegant expression, but yeah. And then we want to just go ahead and store the current data into that position in the vector, right? So this is where we realize we need this integer n, right? So remember when I was going over the lab description, we wanted um, a vector for each of these, which we've already had, and then we also want to make sure that the first record is going to be stored at the 0th index. So since we're going to be incrementing our index for each iteration of the file reading, we should start at -1, right? Because the first thing we're going to do is we're going to increment that index. So we can say okay, plus plus n, or n plus plus, n consequential in this place, or in this case. And then we're just going to go ahead and read each piece of data into its corresponding vector. So we know we're always accepting last name first, so it's going to be last name, then first name, then midterm 1, then midterm 2, and then final score. So let's go ahead and get this in here, and let's format it a little bit. So yeah, we don't generally want our stuff wrapping around like this, so we'll just do 2 for each. So that looks a little bit better. Okay, nice. So the way that we read data in from a file stream is just the way we read it in from standard input. You use the extraction operator here, and you're saying, okay, we're extracting data from the file. See, the arrows always go where the data is going. So it's going from the file stream, into our vector here. And just like our standard input, stream, the data, it will skip all of our white spaces here, in this case just tabs, and then it will read it into the next variable. So we'll say okay. Oh, also keep in mind we have declared our vectors to have size 20, so we don't need to push these back because that space has already been allocated, right? So there's that advantage of knowing the range and making that assumption there. So we're just going to read them in at each index, and then we're going to go ahead and increase that index and repeat the process until there's some failing condition. So if it reaches the end of the file and there's nothing to read in, then this fail will be set as true, and then we will just continue. But what if we fail and we're not done reading in the data? So in that case, we want to go ahead and make an additional check, right? So we want to make sure that if we're not at the end of the file, right, so if we have not finished reading all the data, that we output some sort of error message. And we don't want the program to terminate in this case, because we still want to process the data that we have, but we do want to make sure that the user is aware that there was some issue reading in the data. So if it has failed and it's not the end of the file, just output an error message. Nice and simple there. And then, so big thing to remember here is we always want to close our streams. String streams, file streams, all of it. You want to close it. Yes, there can be little weird to find or hard to find problems if we're not closing our streams. So go ahead and do that. You just use the close function, pretty straightforward there. So now we want to actually take care of our computations. This part is actually not really, difficult here. We're plenty used to looping through data and making computations. So I won't go into too much detail on this. But before we do that, we want to open our output file stream, right? So we've closed our input file stream, and now we want to open our output file stream so that we can write some data to it. So it's the same exact process as opening our input stream, except we're just going to use a different name and have a different error code. Again, on those, just go ahead and look up documentation if you want to know what that's about. And so here we know exactly how much data we have now that we've finished reading it in, because we have this integer n, right? So this integer n got incremented for each record that we have. So we can use that as a looping boundary, right? We can have a for loop to go ahead and loop through each piece of data and calculate the individual the individual grade for each student. Right, so we're just going to loop from 0 to strictly less than n, and then we are going to compute the average for whatever student is at that index. Right, so to compute an average, hopefully you remember, we just go ahead and add up all of the data points and divide by the number of data points. Here we're using 3.0, just so that it's explicitly a double, but as discussed in Lab 1, we don't actually have to do that, but it's better to do it this way for some reason. Oops. So yeah. let's go ahead and continue. So then we just want to use this average to go ahead and determine what exactly it is that we want this student to receive for a grade. Right, so just using the standard scale, just have some branching structure here, and then we assign the string grade that way. And then, so now that we've calculated the grade, we have all the information that we need to go ahead and output to our report.txt file. So again, just like reading in data through a file stream, writing out data to a file is going to have the same sort of syntax, except this time using the insertion operator instead of the extraction operator, because we are writing to a stream. So the data is going from the vector to the stream and into the file. And then remember that we want these separated by tabs, so we have this tab character. And yeah, that is kind of all there is to it for that. So now our file currently contains all of the original data plus the letter grade, and now that all there's left to do is we want to go ahead and compute the overall averages and then just write that to the end. So we want to initialize, don't forget to initialize your data. We're going to initialize all of our sums to 0. We're using doubles here because we're going to eventually be calculating an average, so we initialize them to 0.0. And then we just loop through and calculate all the sums. So again, we know how much data we have, so we can just loop from 0 until we're strictly less than n. And we're just going to increment the sum with each piece of data there. And then when we're done, we will go ahead and calculate. You can make the calculation beforehand if you want, but since it's so small, we can just go ahead and do this inline, and we can say, okay, take our report file stream, output a new line so that we are not directly under a student record. We want to say, okay, we have our averages, and this is our output formatting here. It's saying, okay, so anything that comes after the output is going to be fixed point, and it's going to have 2 figures after the decimal place. We learned about this in chapter 1, and then we're just going to output our averages like so. So yeah, guys, that is, see, I should take my own advice. I almost forgot. We want to close our output file stream. I'm going to go ahead and close that at the end to just for good practice, for good measure. Anyways, I hope you guys have learned a little bit about streams. It's not the most complicated topic we go over this semester, but yeah. Let me know on Piazza or in office hours if you guys have any questions, and I will see you in the next one.